Okay, so today we're going to be reviewing functions and slope. So we're going to be focusing on 3T because this was basically our second test. 8.4b, I can interpret unit rate as the slope of a line. So whenever it asks for the rate of change or the unit rate, we know it's just asking for the slope. 8.4c, I can use data from a table or graph to determine the rate of change or slope. 8.5g, I can identify functions using sets of ordered pairs, tables, mappings, and graphs. So we're going to start off with functions. So this is our first unit that the first topic we're going to be focusing on, functions. Function is a relationship in which every input x has exactly one output y. So to check if it's a function, there are a couple different ways depending on the representation. So for example, if it's an ordered pair or a table, each x value must correspond with exactly one y value, exactly one. Check for repeating x value. So we don't care if it happens to be, if every x in the system has the same y value, as long as it only has one y value. It cannot have two. So we're going to be looking at ordered pairs and tables for this one. So I have two examples, and we'll determine if these are functions or not a function. So it says each x has to have one y. So -3 has 2 and only 2. I don't see -3 anymore over here. -1, only see it once. It only has an output of 5. 1 only has an output of 8. I don't see 1 anywhere over here. And 3 only has an output of 11, no other number. So looking at this, I can determine that it is a function because each x or input only has one output. Now let's go ahead and look at this one. 411, 513, 615, and 717. So again, we're looking at the x's, 4, 5, 6, and 7. One thing we're looking for is if they repeat. No, none of them repeat. 4 has an output of 11, and 4 does not come out again as an x value. 5 has an output of 13, and 5 does not come out again as an x value. 6 has an output of 15, doesn't come out again as an x value, and 7 has an output of 17 and doesn't come out again as an x value. So this one is a function. Now for mappings is another way that we can see it. Each x value must connect to only one y value. So here is my mapping. Remember, it's x, y. So each x value can only have one arrow. So here's my x value, -7, just has one arrow. I do not care what it's pointing to. In fact, I could even cover this as long as it only has one arrow leaving each x value. So -8 only has one arrow leaving it, -9 only has one arrow leaving it. The fact that it only has one arrow tells me that there's only one output for those x values. So this one is a function. And now let's look at a graph. A graph must pass the vertical line test where any vertical line touches the graph at only one point. So we're going to imagine a vertical line, I tend to use my pencil, passing through this entire graph. At any point, if it crosses more than once, it is not a function. So let's see, at this point, it only crosses once. This point only crosses once. This point, however, it crosses twice. It crosses here and here. Therefore, it fails the vertical line test and is not a function. So the same way that over here, each x value must connect to only one y value, the vertical line can only touch one point. If it doesn't, it is not a function. So now let's do some examples. Here I have my ordered pairs, a graph, and a mapping. So we're going to be focusing on the x values. So 1, 2, 3, none of these repeat. Looking at this one, looking at basically just my x values, one line leaving the 6, one line leaving the 7, one line leaving the 8. That means that it is each x value only has one output because it only has one line leaving. It doesn't matter that they're going to the same one. It just matters that it only has one output. So this one also just has one output for every x. And then here, the vertical line test. Imagine a vertical line passing through your graph. At any point, does it touch at more than one spot? So if we do a couple random ones here, looking at it, touches once, touches once, touches once. I don't see any spot where it touches more than once. So every single one of these is a function. Now let's look at these ones. So my x value, 1, 1, 1. So my x values do repeat. Here it's saying 1 gives me the output of 1, but then over here 1 also gives me the output of 2, and it also gives me the output of 3. So it's giving me 3 different outputs even though it's the same x value. Here, imagine my vertical line passing through, crosses twice here, twice over here, a whole lot other places, but even if it crosses once, it is not a function. Here, again, just looking at my x value, 6 goes to 2 different numbers because I have 2 different lines. So this one input is giving me 2 different outputs, both 0 and -2. So this one is, none of these are a function. So that was one topic, functions. Now let's go ahead and do our second topic, slope. Slope is also called rate of change. It can be positive if it's increasing left to right. Now, whenever we're looking at a graph, we're going to be reading it left to right, just like how we read words, read a book, we're reading it left to right. So if it's increasing as we're looking at it from left to right, it's a positive slope. If it's decreasing as we're going left to right, it's a negative slope. A zero slope is a perfectly horizontal line, and undefined is a perfectly vertical line. So we have a formula that we can follow, y2 minus y1 over x2 minus x1. This is just saying our change in y over the change in x. So when we're subtracting, we're just measuring the changes between the two variables. Now, I actually don't even need to memorize this formula. If we look at our formula chart, let's see, slope of a line. We have y2 minus y1 over x2 minus x1. That gives us our slope or rate of change. So we don't even need to memorize that formula. So when we're looking at a graph, if we don't want to get our specific points and subtract them, we can also look at it as rise over run. So remember, with our slope triangles, we can pick any 2 points on this line. So for example, let's say we pick these 2. My rise would have been this. Let's say that our rise was 2 and our run was 2, looking at this slope triangle. But if we're looking at this one, we notice it's a little bit bigger. So let's say our rise was 3 here and our run over here is 3. So we can simplify, put it in our fraction, rise over run. So our rise was 2, our run was 2, 2 over 2 equals 1. Here my rise is 3, my run is 3, and though it may look like 2 different numbers, if we simplify it, 3 over 3 is still just 1. So regardless of which slope triangle we create, whether it's a small one or a big one, we're still going to end up with the same answer once we simplify that. So the ratios of the corresponding sides are equal, which we found here. They were both had a slope of 1, even though this one was a little bit bigger. So we can either do our formula, pick 2 points, subtract them, or just count our rise over our run. So let's look at some examples. Here we have a graph, so we have rise over run. So we're going to be looking at it left to right, just like how we're going to be looking at our slope. So this is my left point, this is my right point. Since I'm going left to right, I'm going to be going from this one to this one. So we're going to start here, and then I'm going to do my rise first. Since that's the one that goes on top, I want to take care of that one first. So rise, it's either going to be going up or down. That's my my y movement. It's along my y-axis. So here I'm going to be going down 1, 2, 3 units. So if we look, we're going down 3. And I just want to make sure that it is actually 3 and we're counting by 1, so it is just 3 units. So my rise is 3. And because I went down 3, it's going to be -3. Now we're going to be going to the right. Going to the right is always a positive movement. So if we're always going left to right, it should always be a positive movement as we're moving along the x-axis. So I'm right here right now. I'm going to go 1, 2 units to get to my point. So this one has a slope of -3 over 2. And I'm going to think, can I simplify that? And if I'm not sure if I can simplify that, luckily we have a calculator that can do that for us. So -3 over 2. If I click just enter, it'll simplify that fraction. So -3 over 2. Or If I also want to convert it to a decimal, I can click Control Enter, and that'll change it to a decimal for me as well. And so we would get negative 1.5. Both of these are correct. My answer could be written in either form on the test, so we want to make sure that we can convert back and forth. This is a table, so remember this is y2 minus y1 or x2 minus x1, or change in y over change in x. So let's find our changes. From 0 to 2, I'm changing by 2, and I'm increasing by 2, so it's going to be plus 2. From negative 2 to 1.4, I'm also increasing. It's getting bigger, and I'm increasing by 3.4. Now, if I wasn't sure how much I was increasing by, I would get what I ended up with, 1.4, minus what I started off with, negative 2. So I have 1.4, what I end up with, minus what I started with. I increased by 3.4. So then it's change in y over change in x. This is the y change, so it's going to be 3.4 over change in x2, and then I'm going to simplify that. 3.4 over 2, Control Enter, I get 1.7. So when I simplify that, 1.7 is my slope for that table. And then lastly, we have some ordered pairs. So you can do this two ways. Either you can put it in a table if that makes it easier for you, x, y. X is 2, y is 6. And then we have negative 2 and 7. And then you can find the change just like we did in the table right now. Or you can just use your slope formula, y2 minus y1. So we're going to label it x1, y1, because this is our first point, and x2, y2, because this is our second point. Remember, it's always x comma y, x comma y. So then let's go ahead and plug this into our formula. So y2 is 7 minus y1 is 6 over x2 is negative 2 minus x1 is 2. So I'm just following this formula, y2 minus y1, x2 minus x1. 7 minus 6 is 1. Negative 2 minus 2 is negative 4. But if you didn't want to do the math yourself, Control Divide, we have our fraction, and we can write 7 minus 6. Negative 2 minus 2. And click Enter. Oops. Type that in wrong, minus 2. Okay, we're looking at this one. Here we go. 7 minus 6, negative 2 minus 2, negative 1 over 4, which we have the same thing. Remember, the negative can go on the top or the bottom. We're only going to write it once, but we could pick which one we want to put it on. So it's negative 1/4. And if I were to change that to a decimal, negative 0.25. You could also, what we did here, it's decreasing by 4, so minus 4, increasing by 1 plus 1, change in y, 1 over change in x, negative 4, we would end up with the same answer. You could also use the slope formula here. You can make this x1, y1, x2, y2, and plug it into your formula also. If you like using the slope formula that's on your formula chart, you can use it also if kind of finding the change confuses you, and just type it in your calculator to subtract it. So now what y'all guys are going to do on your own is your function and not a function card sort. So you're going to be doing this on your own. You have your page of functions that you're going to be sorting through, and you're going to sort them into function, not a function. Once you've sorted them, you're going to staple it along this and kind of stack them all up and then staple them all at once, and then you'll be fine there. Slope, rate of change, and unit rate. So same thing here. If it asks for slope or rate of change or unit rate, it's all going to be finding the same thing. So you're able to do that as well. So y'all guys have those examples. When you're done with that, then you can do the quizzes, practicing this some more.